A monomial is an expression consisting of a number, variable, or product of numbers and variables that have whole number exponents. A monomial cannot have more than one term, and it cannot have a variable in its denominator. Recall a term is a product of numbers and variables. Here are some examples of monomial expressions and expressions that are not monomials, along with the reason why.
Okay, so 5 is a number, x is a variable, 5x is the product of a number and a variable, xy again is the product of two variables, x taken to the 5th power is the product of x 5 times itself, which is also the product of 5 variables. Now let's see if I can get this up here. There's a few that aren't. Oops. Try this again. These are the ones that are not monomials. X plus y is actually the sum of variables. And in the case of 1 over x, as we just learned in the last module, is equal to x to the negative 1. And that does not have a whole number exponent. So in the first example, to expedite things, I already put the answers in place for you guys. We're going to try to determine if 7c squared d is a monomial. Okay, so anyway, it has one term, so that checks. So that means it could be a monomial. It does not have a denominator. Okay. If we were going to split this into parts, its numbers and its variables, 7 times c to the 2nd times d. So that would qualify. And then you can see that 7 is a number, c is a variable, and d is a variable. What are the exponents that go with these? C has an exponent of 2, and D has an exponent of 1, as you can see. The exponent of the variables are all whole numbers, so that means check 7c squared d is a monomial. Okay, now the next one is 7 over w to the 5th. Is that a monomial? Well, no, it's not going to be, because we cannot have a variable in the denominator. So that would be no. It's not a monomial. Okay, here's 2 more examples. X to the 3rd. Is this a monomial? Well, yeah, sure it is, because x to the 3rd is the product of x times x times x. So that would qualify. Is the term the square root of a? Well, not really, because as we learned in module 14, that was it, we just went through, that would be a no, because the square root of a can be written as a to the 1/2. And variables have to have whole number exponents, so that could not be a monomial. Now, is x to the 5th plus 2xy, how about that? Well, no, because a monomial means mono or 1, and monomials can't have more than one term. This actually will be called a binomial once we get to that, because it has more than one term. And then the second example there, v to the 4th over 10, yeah, that's okay. And the reason that's different than the other one is we have a whole number in the denominator. So v to the 4th over 10 is the product of v times v times v times v times 1/10. So yes, that would qualify as a monomial. Okay, well, the little blurb at the top here, when we're in regard to classifying polynomials, a polynomial is going to be anything that's more than 1. But we also know that a binomial has 2 terms and a trinomial has 3. but actually they're both termed polynomials as well. But normally we use 4 or more terms. We would use the term polynomial to classify those, since binomial and trinomial are more specific. Anyway, polynomials are also classified by their degree, not just by their number of terms. And the way that's done is the degree is the greatest value among the sums of the exponents. So when we look at the binomial that's listed there in the middle, 8xy to the square, 8xy squared minus 5x to the third y to the third z, that is 2 terms. The variables in the first term are x and y, and the exponent on x is a 1, the exponent on y is a 2. So the higher one obviously is 2. The number 8 is not a variable, so it has a degree of 0. So 0 plus 1 plus 2 equals 3. The degree of the second term is 0 with the 5, 3 with the x, 3 with the y, and 1 with the z. So when we add those numbers up, that would be 7. Therefore, 8xy squared minus 5x to the third y to the third z, wow, that's a lot, is a 7th degree binomial. It's the one with the highest in that binomial, the one with the higher degree. All right, so let's look at this example. 10 to the 5th plus 7p to the 4th minus 2/3 to the p. Now mind you, we could just change 10 to the 5th, and we could change 2 to the 3rd, make that 8, right? So really the only one that has an exponent, the only variable that has an exponent of any significance is the p in the middle term. The p in the third term is just p to the first. So the degree for this, p to the 4th, gives that full trinomial a degree of 4. And as you can see there, the answer is 4. And now your favorite thing in life, video. Feel free to get up and dance.
There are many parts and features to polynomials, and I want to share some of them with you. We already talked about coefficients. Those are the constant terms in front. But there's also this notion of the degree. Harder to say than you may think, but it turns out the degree of a polynomial is pretty easy to find, even if it's hard to say. It literally is, you just look at the polynomial, and you look for the largest exponent. You look for the largest exponent. So for example, here, I see the exponent on the unknown x is a 2, and here the x is just the first power, so the highest power here is 2. This polynomial has degree 2. This is a second degree polynomial. Want to try another one? Here we go. 5 plus 2m cubed plus 3m to the 6th. We don't care about the coefficients. We're only looking at the highest exponent. So here I see m to the 3rd power. Here I see m to the 6th power. 6 is the...
So what do you think? I'm closing it off for a minute. 6 is the largest, right? So the degree would be 6.
largest. This is a degree 6 polynomial. Notice, by the way, that quite often when we look at polynomials just between the two of us, usually the highest degree is going to be way up in front. But not always, and this is a good example of that. So you really got to search through all the monomials and check every single one to find the highest degree. This is actually of degree 6. How about one last one? H plus 2h cubed plus h squared. Well, again, here we...
Hey, what do you think? Take a guess.
see h to the 1st power, here we see an h to the 3rd power, here we see an h squared. So the highest exponent is 3, so in fact this is a 3rd degree polynomial. So again, the degree of a polynomial is nothing more than the largest exponent that appears on the variables.
All right, so here's an example for you. I want you to try this, and I'm going to close the video down and then go to the board, but you give this a shot. Okay, so you can see here I put the answer up on my whiteboard, And x squared and y squared, we combine those two together and we get 4. X to the first, y to the second in that second term, add those together and we get 3. And xy in the third term of the trinomial is 1 plus 1. So that's the second degree. So the first term dominates here, and we see that's a 4th degree trinomial. So way to go. Oh, you guys got that right. All right, here's your next question. Okay, you're going to classify each polynomial by its degree and number of terms. And the first term is 6ab squared minus 2a squared b. We want to know the degree and whether it is a binomial, trinomial, or a polynomial. Okay, so turn off that video for a second. Everybody got your answer now? Here we go. 6a squared. A is to the first power plus b is to the second power, 1 plus 2. And the second term, a is to the second power, b is to the first, so that's also a 3. So this is a binomial rated 3. And as you can see, the polynomial does have a degree of 3, and it is a binomial. Now, so you can see a little more of the basement. You can see the reflection in the mirror, but that's Saratoga Race Course, which has all the champion horses that have raced there in that picture. And then over here, these pictures are from the 60s, and that's Round Table, who ran at Atlantic City Racetrack on this day and won the United Nations Handicap. Someday I'll show you my horses that ran at Garden State. Assign you some Khan Academy problems. So you're going to definitely need to be signed up for that. And the directions will be on Google Classroom. You'll go through a 2-minute lesson and answer 4 questions. And then that site will report back to me how you did on the 4 questions and the time that you spent on it and that actually you did it. So that'll be your attendance for the day. Now, I'm going to show you one other thing. These seats that I'm sitting in are pretty cool. These were from Veterans Stadium in Philadelphia. So I'll get up so you can see it a little bit better. And you can see over here, look, it's got the logo for the bet right on the side. So if you're not sure what Veterans Stadium is, because you guys are young, ask your parents. They probably went to a lot of Phillies game and Eagles games there, okay? All right, so tomorrow we'll go into this a little bit more. Make sure you do your 4 problems and you look at that short 2-minute video, okay? Thanks.